Hey, this is the 2015 AP Calculus Practice Exam. This video is going to cover number 4 and part of number 6. So number 4 says considering the following differential equation, and it gives you dy dx is x times y minus 1 over 4. On the axis provided, sketch a slope field. Okay, so I don't think I've worked a slope field problem on these videos yet. So would you have one like this on the 2020 test? I really don't know. It's certainly possible. It's in the material that you're supposed to know. But I don't know if it's practical for them to ask one like this, but it's good to go over it one last time. So to get the slope, we just plug the x and y values into the dy dx equation. All right, so for when x is -1 and y is 0, that'd be -1 times -1 over 4, so that'd be 1/4. So x is -1, y is 1, that's going to be 0. When x is -1 and y is 2, that's going to be -1/4. When x is -1 and y is 3, that's going to be, let's see, -1 times 2, so -2 over 4, so -1/2. 0, 0 is 0. When x is 0, it's just going to be 0, right? So that covers the next 4. 1 times -1 when y is 0, so that'd be -1/4. And then 1 and 1, the parentheses will be 0, so that'll be 0. And then 1 times 1/4 when y is 2. And then 1/2 for 1 and 3. Did I get that right? So 1 times 2 over 4 would be 2/4 or 1/2. All right, I will draw the slope field in red. So let's get the zeros first. So that's at 0, 0. At 0, 1, 0, 2, and 0, 3. So those are pretty easy. So -1, 0, we have a slope of 1/4. So that's just a slight rise like that. At -1, 1, we have a slope of 0. At -1, 2, we have a slope of -1/4. And then at -1, 3, we have a slope of -1/2. So just make sure it's just a little steeper than the -1/4 there. All right, at 1, 0, that one is downhill, just barely, -1/4. And then another 0, and then a +1/4, and a +1/2. So there you go, a slope field problem. Not hard on that. Just don't get in a hurry, too much of a hurry, and make yourself a chart of the slopes, and then that's easy points. Okay, go ahead and pause the video if you need to, and we will go on to part B. Okay, part B says let f of x be a particular solution to the differential equation with initial condition f of 1 is equal to 3. Write an equation for the line tangent to the graph at the point 1, 3 and use it to approximate f of 1.4. Okay, so our tangent line equation, y minus y1 is equal to the slope times x minus x1. We have y1, that's going to be 3, and we have x1, that's going to be 1. We just need to figure out the slope at 1, 3. So we just plug that right into dy dx here. Okay, so x is 1, y is 3 minus 1 over 4. So that's going to be 2 over 4, which is 1/2. So our tangent line equation is y minus 3 is equal to 1/2 times x minus 1. So y of 1.4 is going to be, let's move the negative 3 over to the right. So that'll be 3 plus 1/2 times 1.4 minus 1. So 3 plus 1/2 times 0.4, so that would be 0.2. So that answer is 3.2. That's a great problem. I can definitely see them forcing you to do that on the 2020 test. And part C is another one that is just highly likely that they will force you to do this. So pause the video if you need to. Okay, that was part B, by the way. Didn't label that. So part C, we have to separate our variables and get the particular solution at 1, 3. F of 1 is equal to 3. Okay, so separating the variables, what I'm going to do is bring that y minus 1 underneath the dy. And then x over 4, I'm going to write that as 1/4 x, because I'm just better at thinking that way, and then dx. So I brought the y minus 1 underneath, and then multiplied both sides by dx. Now we have to integrate both sides. So integrating dy over y minus 1, that's the natural log of the absolute value of y minus 1. And then to integrate 1/4 x, that would be x squared, but we'd need a 1/8 out front, plus c. All right, so you've already, these points are usually worth 5 points total. These problems are worth 5 points total. You've just picked up 2, all right? 1 for separating the variables, 1 for integrating. The third one would be to find the constant of integration. So at f of 1 equals 3, you're going to have the natural log of the absolute value of 3 minus 1, which is 2. We can get rid of the absolute value sign since it's positive 2. Is equal to 1/8 times 1, right? Plugging in 1, it's just 1/8 plus c. So c is equal to the natural log of 2 minus 1/8. Boom. Now you are at 3 out of 5 points. Okay? So you've already got more than half. You're already doing great. Okay, now let's plug c in. So we'd have the natural log, and since we know x is, in this particular situation, it's greater than 0, we can just use parentheses now, since we know that it's going to be greater than 0. We don't need the absolute value symbol anymore. Is equal to 1/8 x squared plus the natural log of 2 minus 1/8. So now we have 4 out of our 5 points. So how do we get to a y? Well, we have to exponentiate both sides. Okay, so I'm not going to go crazy on this. If we exponentiate both sides, of course, the e and the natural log cancel out, and you would have y minus 1 is equal to e to the 1/8 x squared plus the natural log of 2 minus 1/8. So moving the negative 1 to the right, 1 plus e to the 1/8 x squared plus natural log of 2 minus 1/8. We could do more. Okay, e to the natural log of 2 is 2, so I guess we could bring the 2 out front there, but I'm not gonna do that. I'm just gonna leave it like this. Make them count off because they really can't. So you have separated the variables, and even if you don't get this last part right, you get 80% of it right, okay? And so 80% is a 5 in AP Calculus land. In fact, it's way above a 5. So really, to get a 5, you're looking for 60%. Okay, so that's number 4. I am not going to work all of number 6. Number 5 is one that would not be on the test. I'm just going to work A and B on number 6, so I'll give you a chance to find that problem while I'm giving myself a chance. Okay, number 6 says let g of x equal 4 times x plus 1 to the minus 2/3. All right, and then it says f of x is defined as 0 to x of g of t dt. So what that means is f prime of x is you just plug in the upper limit x into t there. So f prime of x is equal to g of x. Okay, so part A says find f of 26. Okay, so to get f of 26, since we know that g of x is also, this is f prime of x. So g of x is equal to f prime of x. So what you have to do in order to get f of 26 is to integrate from 0 to 26. So we plug the 26 in for x of f prime of x. f4 times x plus 1 to the minus 2/3 dx. All right, so I'm going to bring that 4 out front. We'd have x plus 1 to the minus 2/3. So this is pretty, since we don't need to use a u substitution because the derivative of the blop is 1. So let's add 1 to negative 2/3. So that's going to be x plus 1 to the positive 1/3, but I'm going to need a 3 out front. And don't forget that 4 out front also. So 4 times, so just to make sure, just take the derivative of this. 1/3 times 3 is 1 times x plus 1 to the minus 2/3 times the derivative of the blop, that's 1. So that's going to be 12 times x plus 1 to the 1/3, and we have to evaluate that from 0 to 26. So that's 12 times 26 plus 1, 27 to the 1/3. All right, so minus 12 times 0 plus 1 is 1 to the 1/3. So 27 to the 1/3 is not 9, it is 3. Okay, so 12 times 3 is 36. Minus 1 to the 1/3 is just 1, so 36 minus 12 is 24. All right, they could ask you one like that, they really could. One that we've covered a lot during AP practice, but not so much in our textbook. All right, so that's part A. We're going to do part B, and then this video will be over. Okay, so determine the concavity of y equals f of x. Okay, so we already know that f prime of x is equal to 4 times x plus 1 to the minus 2/3. What do we need to do to get concavity? We need to find the second derivative. Okay, so f double prime of x, negative 2/3 times 4, bring that out front, that's negative 8/3, times x plus 1, subtract 3/3, so that would be negative 5/3. Then times the derivative of the blop, which is just 1. So that's going to be negative 8 over x plus 1 to the positive 5/3. Now it says for x is greater than 0. So when x is greater than 0, so again, that's the second derivative. When x is greater than 0, you know that the bottom is going to be positive. We're going to have a negative 8 over a positive number, so that is always negative. So when the second derivative is negative, the graph is always concave down. Don't write CCD on your paper like we did in our class. They may not be cool with that. So there you go. 2020 videos are complete. I can't say that I'm upset about stopping making these, but I hope that they have helped you. And I won't be talking to you next video because I'm not going to be making any more, at least for this class. All right, good luck on the test next Tuesday, and I will talk to you soon.